yeah, it'll be important in certain circumstances to not only have a vector, but to have just a vector that's a unit size, which means magnitude 1. So by unit vector, we just mean a vector that has the magnitude of 1. And so what we want to do is we want to take, say we've got this vector A, and we want to unitize it, if that's a word or not, but take that vector down to, it has the same direction, but the magnitude of it is just 1. And so for obvious reasons, yeah, we call the unit vector U. And so vector U is going to be 1 unit long, and it's in the same direction as A, but that U is the unit vector of a particular vector. You know, if you have more than one vector, I guess, you know, you might need to put a little subscript or something to say which unit vector it is, but that's what we mean by unit vector. Vector in the same direction, just that its magnitude is 1. Whatever the length of A is, the unit vector of A will have a, well, how do we get a unit vector out of A? Well, it's just a little formula, you know, build your formula sheet here as we go along. Here's another one. The unit vector is, all you have to do is take the vector and multiply it by 1 over its magnitude. So you can write it that way, or you could just write it A divided by the magnitude of A. So just divide a vector by its magnitude, and that gives you unit length is 1 there. The magnitude of it is 1. Yeah, so that that's easy enough to show that does it, because all we did here, we know it's in the same direction, because just let C be 1 over the magnitude of A. You're right, that's just a number, so that's our scalar amount. And so all we're doing here is we're multiplying A by C, right? We're multiplying it by a scalar, and we know that multiplying by a scalar, that keeps the same direction as the particular vector, so we know because of that. And then if we take a look at the magnitude of U, which is it would just be that, whatever that the magnitude of this thing. So we've got U as some multiplier times A, and so that magnitude is the same as that magnitude there. Well, yeah, this is just equal to magnitude of C times magnitude of A, but the magnitude of C is just a number, and so that's going to be its magnitude. So C, those two just cancel out. Magnitude. So it does give us a size 1 magnitude vector. So anyway, so that's our important formula there. So that's how you find the unit vector. So let's find the unit vector in the direction of A equals 3I plus J minus 4K. So yeah, it's just A divided by its magnitude, or however you want to write it the other way, that's fine. But so what would that be? It'd be A divided by, what's the magnitude here? Just do the square root of the sum of the squares. So it'd be 9 plus 1 plus 16. So we're going to take A, which I guess we're going to put it up here. Those would be divided by, is that 26? Square root of 26? So typically what they do is go ahead and write those components out. I mean, that's certainly equivalent, but sometimes I guess you might have cancellation here on these numbers. So 3 divided by the square root of 26i plus 1 over square root of 26j minus 4 over the square root of 26. Okay, yeah, if we had the square root canceled or simplified a little bit, you might have some simplifying there to do, but that's it. That would be the unit vector. So that vector would be the same direction, but magnitude is just 1. Okay? And, you know, they might, usually I guess, if they put the vector in the IJK form, they'll probably put the answer in IJK form, or if they put it in the other form, that might be the form they use there, but either one's fine. Is that okay? Question, concern? Yeah, so that finishes off that one.